Hi, my name is Julia Benz. Today I will discuss the findings and implications of my undergraduate thesis on leading emissions reduction opportunities and renewable technologies for oil and gas production. We are going to rely on oil and gas for the foreseeable future. Developing countries will demand more energy, and even if all electricity were generated by renewables, we would still rely on many oil products from plastic to pavement. Additionally, oil and gas resources are increasingly unconventional, with varying compositions, and wide-ranging emissions required for extraction and processing. Renewables can help shrink oil climate footprints. But in order to deploy renewables in oil production, resources must be evaluated on an asset level. Though the entire petroleum supply chain deserves another look, I focus solely on production, the very first step. In this thesis, I asked, how can oil and gas production most effectively lower emissions technologically and politically? I evaluated 3 oil and gas fields using different emission reduction techniques to explore the feasibility of each project. Working with my advisor, Deborah Gordon, and her colleague Adam Brandt's oil and gas production greenhouse gas emissions model, called OPGI, I was able to estimate the emissions reduction potential for each field. I also assessed what policies work best to implement greenhouse gas reductions at each field. Here are my emissions results. California Midway Sunset, a massive heavy oil field, requires significant energy to generate and inject steam underground to make oil flow to the surface. Instead of using natural gas, employing solar steam for 75% of the energy input could potentially cut greenhouse gas emissions by an estimated 53%. Ekofisk, an offshore gassy field in Norway, could reduce its production emissions by an estimated 32% by re-injecting essentially all of its gas and using onshore hydroelectric power for its production operations. Gorgon, the acid gas field in Australia, with its naturally high carbon dioxide levels, could successfully employ carbon capture and storage, which at full capacity could reduce production emissions by almost 60%. Here are my final results and policy analysis. In the case of Midway Sunset, California, emissions regulations have incentivized solar steam pilot programs, but more aggressive implementation could vastly expand emission reductions for heavy oil production. In the case of Ekofisk, Norway's high carbon tax and strict regulatory requirements have made gas reinjection and reduced flaring routine, but additional policy enactments will be required to electrify offshore rigs, use renewable power, and decommission assets when they can no longer comply. In the case of Gorgon, it is not enough to require emission reduction technologies like carbon capture and storage for permit approvals. Governments must ensure successful, timely operation in order to prevent millions of tons of carbon dioxide from illegally being emitted. In each case, I discovered that timely, trusted, routine, standardized data collection is critical to increase transparency to inform effective public and private decision-making. In conclusion, oil and gas sector emissions can be greatly reduced using renewable technologies in production, and this finding is likely consistent along the rest of the supply chain. Emission reduction technologies should prioritize emission reductions and should not be used to extend the lives of highly emitting fields or allow the development of otherwise climate-intensive resources. Finally, policymakers should provide increased data transparency in the oil and gas sector, as well as create clear expectations through binding regulations that are strictly implemented and routinely updated. Thank you for listening.